everyone, we're going to practice solving rational equations. This is 4 problems I chose because they are very similar, and the next video will have another set that are more similar in nature. So let's get started. I didn't work these before, so if you think I made a mistake, just leave a comment and I will fix it. Okay, so we're going to start with the first one. I wrote this one out already. And just note that this piece right here, if you factor it, will be x plus 3 times x plus 4. Usually when solving this, when you first start solving, the factors are easily obtained just by looking at these factors. Okay, the first thing we want to do is determine what x cannot be. What will make the denominator 0? So for this first piece, it would be x can't be negative 3. And for this piece here, x cannot be negative 4. And that would include, this third piece here. So we have 3 pieces here. Now what I'm going to do is clear the fractions by multiplying by the LCD. The LCD is this. This is your LCD right here. You have to take both of them. And just think about it. You want all factors to be able to go into this. So I'm going to write this equation again. And this time in factored form. And I'm going to multiply each piece by my LCD, which is x plus 3 times x plus 4. And I'm just going to distribute this to the 3 pieces, or the 3 terms here. So basically, the way I do it is you can look at this and cross this out with this piece here. And you can ask yourself also what's missing. So when you're looking at this, what piece is missing? It's the x plus 4. So that's what we're going to multiply it by, 2 times x plus 4. In this piece, what's missing? The x plus 3. So it's going to be 3 times x plus 3 equals, and in the last case, when we're distributing here, these two cancel, and we're just left with 7. So I'm going to distribute and simplify this. And hopefully I'm doing this right. So that's 5x plus 17 equals 7. You subtract the 17, you get 5x equals negative 10. So x is negative 2. And what I want to do is I want to make sure and check my solutions. It's not in my restrictions on my domain here, so that's my solution. Okay, the next 3 problems are very similar. So let me write it out. We have 4 over x minus 5 plus 1 over x plus 2 equals 2x plus 7, and I'm going to go ahead and factor this, x minus 5 times x plus 2. So by looking at each of these pieces here, x cannot be 5 and x cannot be negative 2, because that would make the denominator 0. Those are my restrictions. That's your first step. Now my LCD is just this piece right here. So I'm going to write this equation again. And I'm just going to multiply this whole thing, each piece, by my LCD. So this equals your LCD. And that's going to be x minus 5 times x plus 2. And we're going to multiply it by each piece. And what happens is the x minus 5's cancel, but I still have to multiply it by x plus 2. So you have 4 times x plus 2. What's missing here is your x minus 5, so that's just plus x minus 5. And in this last case, this whole thing cancels. So you get 2x plus 7. We simplify, we get 4x plus 8 plus x minus 5 equals 2x plus 7. I get 5x from this piece and minus 3 from these two equals 2x minus plus 7. So I'm going to subtract the 2x and add the 3. And I'm left with 3x equals, when I add the 3 I get 10. So x is 10/3. Okay, and this is fine. It doesn't, it's not in my restrictions, so we're good to go. Okay, the next problem is going to be a minus 30 over, I'm going to go ahead and factor it based on my other factors, x plus 7. Oh, it's not x, I hate that. I have to use a. So a plus 7 times a minus 3 equals 5 over divided by a plus 7 minus 2 divided by a minus 3. So my restrictions are x cannot be negative 7. That would make the denominator 0 here. And x cannot be 3. We have to be really careful here because of this negative. So this one we want to be careful with. I'm going to take this and multiply this whole thing by my LCD. My LCD is this. So when we multiply, let me see if I can fit it in. I'll just rewrite it. So we're going to multiply both sides of the equation by a plus 7 times a minus 3 times this, 8 minus 30 over a plus 7 times a minus 3 equals a plus 7 times a minus 3 times, I'm going to squeeze it in here, 5 over a plus 7 minus 2 over a minus 3. So I'm multiplying this by both pieces. It's kind of stuck it in there. Well, what happens here, that just cancels, so we get a minus 30. And in this case, I just see what's missing. So the a minus 3, so you get 5 times a minus 3 minus 2 times a plus 7. Okay, because this would cancel and you get a minus 3, and this would cancel. Alright, now clean it up. You get a minus 30 equals 5a minus 15. Make sure here you distribute the negative or you're going to get the wrong answer. So it's minus 2a minus 14, not plus 14. Now I'm going to clean this up. A minus 30 equals 3a minus 29. Now what I'm going to do is subtract a, and I'm going to add 29 to both sides. So this gives me, add 29, I get negative 1 equals 2a, because that would cancel. So a equals negative 1/2, which is fine because it doesn't, we don't have an extraneous root. Okay, the last one we have is 1 over d minus 7 plus d over d minus 2 equals 5. I'm going to factor this. It's d minus 7 times d minus 2. Alright, so quickly, d cannot be 7 and d cannot be 2. I multiply by my LCD, which is just this part here. That's d minus 7 times d minus 2 to each of these pieces. So I'm going to get, this would cancel out and I get d minus 2. So you get d minus 2 times 1. So that's just times 1 plus d times d minus 7 equals, this just cancels, so we just get equals 5. Now simplify this and we get d minus 2 plus d squared minus 7d equals 5. Since we have a square there, what we're going to do is move everything over to the left. These two would be minus 6d. You subtract 5, so that's going to be minus 7 equals 0. Then you factor, and you get d minus 7 times d plus 1 equals 0. So we get d equals 7, and d equals negative 1. So if we look at this, what happens, look at this one. D equals 7. Well, D can't be 7. Because if D is 7, then you're dividing by 0, and you can't do that in math. So we have to disregard this. This is an extraneous root, and only have one solution, which is D equals negative 1. Okay, that's all. The next problems we're going to do are more like this quadratic type, where you're going to have to really check for extraneous roots. And that's all of this one. The next one's going to be 5 problems. Bye-bye.